Yes. Welcome everybody. We are a little bit in front of time. We have still 1 minute to 11, but let's give a couple of minutes for attendees to come to our webinar, and we will start shortly. All right, 2 minutes past 11. Let's start it. Hello everybody, and welcome into our webinar, Create Magic with the Data and MQTT plus Node-RED. And this webinar is slightly different from our webinars so far. It will not focus on the data or on the systems what FlashEye is doing, but it will help understanding what can you do with 3D data and how easily you can combine it with different systems and different software. So I will start I will start with some agenda, and first I will just quickly introduce what we as a FlashEye are doing, then jump into the what is MQTT, a little bit about MQTT Explorer, Node-RED, and LiDAR over MQTT. Then we will have time for questions and answers, and we will wrap up this webinar with some key takeaways, which I hope everyone from you will like and get it with you. So just briefly, for those who are new in this webinar in our LiDAR or FlashEye Academy, we at FlashEye, we are developing a software for 3D LiDARs, which is easy to use and support multiple different brands. And basically, as for the users, there is no coding and no experts needed to set up the systems. And as you will see today, everyone, non-programmer people, can use the data and the analysis from our software to create something new, something else, something on top of the only LiDAR systems. And our vision is to improve safety and mitigate dependency on the personnel, so everything will be more reliable and independent on human weaknesses. And we as a company, we decide to share the knowledge. This is something which we believe it is very important, and since also this technology is fairly new, this technology in different industries is really fresh. So we are taking this opportunity to present what is basically state of the art, what can be done, what can be used for, and yes, this is something which we decided to run, such a webinars, workshops, and so on. So jumping in quickly to the MQTT. What is the MQTT? It is a message querying telemetry transport. So this is basically a communication protocol. It is nothing new on the market. It has been created in 1999, so quite a mature protocol, but currently very widely used in, for example, IoT. People behind this protocol comes from IBM, Microsoft, and Eurotech, and MQTT relies on the TCP protocol for the data transmission, but also there is a new variant which is called MQTT SN, which use other kind of transportation such UDP or Bluetooth, which can be used in smart buildings or any other applications. The architecture of the MQTT is based on broker and client, means there is a broker which receives all the data and distribute it along the clients, or the clients can request the data from the broker. It is based on the subscriber and publisher ideology. So you can have a client which subscribes and receives only the data. You can have a publisher which sends the data out. For example, on this graph, you can see some temperature sensors which are publishing temperature data. Then there is, for example, the controller for the light, which is a subscriber which gets the data from the broker when the light's supposed to be turned on and off. And then you have a laptop and smartphone, which is basically a visualization part or a command for the light to turn it on and off. Also, MQTT supports point-to-point connectivity. All the data is sent over the topics, and topics contains payloads. And this I will show a little bit later how it looks in the structure, but this is a basic architecture which you can have in your mind when you're thinking about MQTT. The most important part is a broker, and have it stable broker installed and equipped in a proper network. Then MQTT protocol supports quality of service, and it have 3 levels of quality of service. The first one is they call it at most once, so messages are delivered at most once without any confirmation. So basically there is no check if the message has been delivered. Quality of service 1, which is at least once. Then messages are delivered at least once with confirmation required, so needs to be this confirmation from the receiving part. And quality of service 2, exactly once, where there is a message are delivered exactly once through a 4-step handshake, which it takes the most of the bandwidth, the most of the time, but will ensure that your message has been delivered properly. The standard supports retained messages. So basically, those are very special messages which are stored in a broker and sent to subscribers when the subscriber requests specific topic. Where all the messages which are just published, they are disappearing from the broker. And if, for example, some client will connect to the broker after some message has been published, will not be able to receive this message again. But if this message will have retained flag, the broker will store this message, and all the clients, all the subscribers which are will be connected to the broker after message has been sent will get this retained message, which can be very useful in some applications and will also limit the bandwidth that the message does not need to be resent over and over. It can be stored in the broker, and whenever a new message is coming, then it will be updated. It also supports something called last will and testament. So basically, this is something which can be stored also in a broker, and this is a very specific message which it will allow to send or will be sent whenever the client will be disconnected. So for example, you can imagine when a sensor or some actuator is physically disconnected from the system, will lose the communication with the broker, then the broker still can broadcast this last will and testament from device which was just disconnected from the network, which also gives information that something is happening with the network, something is happening with some clients, and can be used in a way that proper actions can be done, or debug information for the developer of the network can be properly shown. Then also we have multiple security measures within MQTT protocol and some good kind of ideas how to use this protocol in a secure way. And the most basic one is TLS and SSL support. This protocol supports both of those transport layer security and secure socket layers. Also, it supports authentication, the simplest one, username and password, or more advanced with client certificates or token-based authentication. Also, it supports authorization. So basically, by authorization, you can determine which client is allowed to perform what kind of actions. If this client can perform subscription, or the other client performs publishing, or both of those. So in this way, you can really limit some. You can determine proper actions in the network. Also, it supports virtual private networks for network segmentation. So you can basically isolate MQTT network in VPN and basically reduce the risk of unauthorized access or attacks. And also it supports message encryption for communication between the clients and brokers, and also end-to-end encryption mechanism can be implemented to encrypt messages themselves. So overall, it can be quite a secure protocol and can be used in if it is used in a proper way. That was a little bit about MQTT, just basics about MQTT. I will just quickly highlight one software which I will use later on to show you some data snapshots. This software is called MQTT Explorer. So basically, this is a software in which supports a variety of operating systems: Windows, Linux, Mac OS, and so on. And it is visualizing in a very nice way what kind of topics are available, what kind of data, what kind of clients are connected to the brokers. And it is a very easy way to get the data, to read the data through if you are developing, for example, new client, or you are developing the device which will be working with MQTT. And then another software which is very useful, which also was in the title of our webinar today, it is Node-RED. And this is an open source software. You can think about it as a visual programming. It supports Node ecosystem, and it is flow-based programming. It has a lot of different kinds of integrations, and I strongly, if you never tried Node-RED, I strongly recommend to have a look, because maybe it is something which can be very useful for your projects, or also for a hobby project if you don't see this really connection with your professional work. And this is how the typical screen of Node-RED Flow looks like. You have default nodes on the left side, which you can select from. You have the main window where you are creating your flow in the middle, and then you can display some information on the right side of the screen. And in this flow, you can see that we have there is a broker node. This is the first node, first block on the left side with text FlashEye EdgeCam event. And you have status indicator as well, that this one is connected. And then you have several different nodes which basically deal with the data read from the topics. And this is in the same this software is based on MQTT style. So again, you have the topics, you have in the topics you have payloads, and basically you have a broker, which in this case you have this FlashEye EdgeCam. FlashEye is a broker, and then EdgeCam event is a topic which we are subscribing. And then further nodes like night switch, zone switch, and so on. Those are the nodes which are dealing with the data with a payload which is included in the topic. And just if you're curious what this flow is about, basically it is taking the information from the LiDAR system, converting it to basically binary information to turn on and off the light in place. So you have this night switch, which basically distinguish if there is a night or day. You can specify GPS coordinates of the place where you are working with, and then simply say that you want to activate it only during the night time or between sunset and sunrise. Then you are switching between zones. You can have multiple zones, and those zones are coming from the LiDAR system. And then simple start stop from the zone, and then at the end activate the digital output, which is connected to MQTT enabled DIO relay switch. Something which I didn't mention yet, there is a huge variety of the devices which are supporting natively MQTT protocol. So if you have some project in your mind, you can search for those devices. In this case, we are using digital output relay block, which is basically equipped with 16 relays, and you can address them from the MQTT and get the data out, digital data, you can say, or on off for LiDAR or for other devices. As I said before, Node-RED supports is basically like a programming layer for MQTT, graphical programming layer, and it supports all those good features which MQTT broker and nodes and so on supports. So in this case, here I'm specifying where is the broker in our network. It is called server in this window, and then you can specify port, you can specify which kind of protocol and so on, also keep alive parameter. Then you can add a security layer with username and password if broker supports that. and at the end you can have this retain messages. You can specify what kind of quality of service you want to work with, and so on. So basically all this information which I was giving before about MQTT, they are already in the Node-RED, which you can in a nice graphical way specify. And why we decided to talk about MQTT and Node-RED? Basically, there is a huge variety of different kinds of devices which supports those protocols, or this protocol. Multiple different sensors, digital outputs, actuators, which can be used both in industry, in home projects, in IoTs, in smart buildings. So this is something which is widely available on the market. Also, there is a huge library of predefined nodes and flows. So, like I mentioned, this night switch. This is basically a like timer switch, which gives you possibility to define in a very easy way where this switching you wanna have. So, for example, in the case of light, it was just a simple finding GPS coordinates of the place where I want to have this night switch and select parameters like sunrise and sunset, and then I don't really need to think when the sunset and sunrise will happen at this particular place in the globe, because this node will know it on its own directly because of the math behind all this kind of predefined things which are created in this node. So it's very simple to use and quite powerful. And you can find some example nodes on the link which I also included in the slide, flows.node-red.org, and all the documentation and all the information about Node-RED you can find as well in the same website. So now, why we are talking about MQTT in general in terms of LiDAR, because we at FlashEye, we are developing the software for the 3D LiDARs, and are we sending 3D data over MQTT? Not really, but we are sending actionable data, something which basically can be detected or can be provided by our system, like analysis of events based on 3D zones, alarms based on 3D zones, some tracking in, since our software tracks everything in the field of view of the 3D LiDAR, and also classification. So you can build some different kind of logic, let's say in Node-RED, based on the classification we are providing from the LiDAR data. So what kind of data, for example, you can think of? Events. This is something which, if you create a zone in a FlashEye software, 3D zone in a FlashEye software, which is covered by LiDAR, and someone or something will enter this zone, will trigger this zone, you will receive event start, and you will receive information like object class, object ID, and also a Unix timestamp. Moreover, you will get the zone ID, so you can exactly know in which area this has happened. If you, for example, name the zones, you will receive also the name of this zone and zone type, since our software supports different kinds of zone types. For example, motion detection, which reacts on any kind of motion. We support object detection, which will send event only when specified object class will be in this zone. And you receive this event start information. After a while, you will receive event stop, and then you can build the logic based on such data. And for example, moving back to the slide when I was showing you simple flow for light control, it was based on the event information. So the light was turning on in the area, in the zone where the class human or car has been detected, and then it was on for X amount of minutes, and after we have received event stop. So this is something simple. You can use 3D data in connection with MQTT and Node-RED and some other outputs. Then we have alarms, and this is slightly different from events. Event, you will, as I said, you will have only event start and event stop, where alarms you will continuously receive in the frequency of the sensor. So usually in 10 Hertz, you will receive information that still there is object in the zone, or there is X amount of points in the zone. And you can use it in different ways, either to be sure that something is still happening in such a zone. You will get information about how many points triggers the zone. So basically you can utilize this information as well. And yeah, it's lightweight information which can be used for many different purposes. And also you are getting zone ID, zone name, object ID, and predicted class as well. If the object is unclassified, you will get empty string in a predicted class. So you can also have this information and filter it further on, that if predicted class is empty, do that, or if predicted class is specified, do another thing. Then we have classification. If you are just interested what kind of objects are in the area where you have the LiDAR system, you can subscribe to the topic called classification, and then in the payload you will receive a list of objects which are in this in basically visible field of view of the LiDAR. So default classes in our system, the classes which you get right away when you just start our system, is human, car, and truck. But for those who are not familiar with FlashEye system, you can create new classes basically by giving minimum and maximum dimensions of the object, and then define the name, and you can add unlimited amount of classes. So you can easily create classes like animals or small animal, big animal, let's say drone or flying object, or whatever class you are expecting or you want to search in the area where you have our system. And then in this classification you will get list of the classified objects. And the last topic which we are publishing, which is, I would say, the heaviest, it contains the most information from the 3D LiDAR software, is a tracking topic. In this topic you will have all the information about every object in the field of view of the 3D LiDAR which is tracked. You will get unique ID, you will get speed of the object, you will have sensor name. Since our software supports multi-sensor installations, sometimes you want to know which sensor has detected that object. And also you will get predicted class. Then moreover you will receive position information, which is based on center of mass coordinates in respect of the sensor. Sensor is our origin, then the coordinates are based on distance from the sensor, and also previous center of mass. So if you want to, for example, store the path, you can basically store those points and create your heat map or use it in a different ways. Then we have some information about bounding boxes. Bounding boxes is something which we are creating around objects, and this can determine the dimensions of the objects. And here you have both size, you have angle of the bounding boxes, and all the transformations. Those things are available in the tracking information. Then also you have a gravity bounding box. This is similar to the object-oriented bounding box, but considering the gravity, which if the sensor is equipped with the IMU, if the 3D LiDAR is equipped with IMU sensor, it is taken from the IMU. If the LiDAR is not supporting, it does not include IMU sensor built in, it is estimated based on our system, based on the movement of the objects. And also it provides the tracking information. Tracking topic provides rotation information of the objects, and yes, you can use it for different purposes. You can build the logic on top of all those data. So the question, as which was asked before, if the LiDAR data is streamed over MQTT, no, it is not, but LiDAR actionable data is streamed over MQTT, and it can be used for different kind of projects, for different kind of applications. And what we have in our mind, and this is not limited to what I say, is basically just a start of discussion, just a start for you to think about applications like smart buildings, automation, alarm systems, or some industrial applications. This is basically the indicators where you can think of having MQTT based systems or connection between other systems and the LiDAR system over the MQTT. This gives quite big flexibility and allows you to create high-level logic, which not necessarily must be included in 3D LiDAR software. We are including a lot of logic directly into our FlashEye software, but still, this higher-level simple functions like creating the switch based on the time, or logic based on number of objects visible, this we are leaving for higher level programming. And then, do we have some questions? Right now I don't see any questions, but if there will be questions, really feel free to send them to us over the email, or you will find contact page on our website. And there is a couple of key takeaways which I would like you to take with you from this webinar. Number one is that you can start with MQTT even today. It is very simple protocol, very powerful protocol, and you can find it extremely useful in many different applications. It is very easy and quick way to integrate completely different technologies together. So, for example, information from 3D LiDAR system together with I don't know, like alarm system, or light switches, or ventilation systems. If, for example, you have a smart building and you want to control ventilation in the building in a smart way to make it energy efficient, you can use LiDAR system to know how many people is in the building, or is particularly in the floor, and then over MQTT with help of Node-RED create a logic to work with the ventilation systems. And one thing which I also want you to take with you is that LiDAR is a great addition to already existing systems. So something which haven't been possible before, or was very difficult or not reliable to do before. For example, detecting how many objects are in the space, how many humans are walking, or if there is a car, what kind of velocity of the car, what kind of velocity of the human. Those kind of information you can get very easily over MQTT to some further systems and build advanced logic on top of that. And we are a little bit on before time, but this I just would like you to think a little bit what kind of projects you would see this technology, what kind of projects, what kind of ideas you would have, what value you can find by using MQTT and, for example, Node-RED together with the LiDAR systems, where you can apply it in your everyday work, or maybe you have someone who would benefit from such technology. So if you have some ideas, if you have some something in your mind, feel free to contact us or forward information about us to your colleagues. And with that, I would like to thank you for today and wish you a great day.